So a scatter plot is used in real world situations, and it's very common. As you guys go farther on in high school and you go into college, you'll use them a lot, especially with experiments, because in truth, with the exception of like math, most experiments have some variance, right? If I'm a good 3-point shooter and I shoot 23 points a day, and I record how many I miss and how many I get, am I going to have a bad day occasionally?
Yes.
We call that an outlier, right? Am I going to have an exceptionally good day occasionally? Yes. But most of my shots are going to be in this one zone, aren't they? Hopefully I'm not an erratic player and every shot is everywhere. That would make me not much of a basketball player. Hopefully, if I'm a 3-point shooter, all my 3-point shots are kind of tightly packed into one area. And I've got a few exceptionally good and a few exceptionally bad, but I don't have everywhere. That's what scatter plots are used for. They let us determine that data. So a scatter plot is just that. It's a bunch of points graphed. If I can give two coordinates, an x and a y, to a situation, like hours per day, or months per year, or dollars per hour, or inches per pound, I can make a scatter plot. So a cluster. We have a cluster, and you'll notice right over here there's a cluster. Whoops, as I broke this pencil. There's a cluster right here, and a cluster right here, right?
Those two are outliers.
I suck at these pencils.
That's why you're an outlier. Whoever stole it.
The ones in the middle are outliers.
Okay. Shh. So there is too much conversation. So a cluster. Yes, ma'am.
Two pencils up here.
I know. But there was the one on my desk already. I sharpened it earlier, so I'd be ready.
Are you sure it's not behind those stacked papers?
I'm sure. I set it right on my desk so I'd have it.
Wait, trace back. Just take a few steps.
Listen, focus, you all.
Hi, guys.
What are you doing? Go sit down. So, a cluster is a group of data points that are pretty tied in. There are two good clusters on this graph. Can you see them?
Yes, sir.
Now, an outlier is a data point that's way different from the rest. Now, this is definitely an outlier. And you should be writing this on your notes.
Outlier.
Now, is this one so much an outlier?
Yes.
I would not call it an outlier. It's kind of in the, because if you look, this cluster kind of roams this way, doesn't it?
Yeah, it's pretty close.
So it's kind of in there. So this is an outlier, but I wouldn't call this an outlier. I would just say it's not in the clusters. Why is there still conversations going on?
It's like a person who's like in groups but not in groups.
Right.
Like metalloids.
Okay. So let's talk about association. Today is really about association. So association, when we get data, we're going to get there. We can actually give it a line. We call that a trend line. That's for tomorrow. But for data, a lot of times we'll talk about association. A positive association means when one goes up, I need you guys to stop talking, Haley. Okay, we should be not requiring talking at this point. Why's your backpack there? So, association, when we talk positive association, it means both sets increase together. This is a positive association. You'll look at this. This is roughly a line like this, if I drew a line through it, right? It's a positive association. As one point rises, the other point rises too. That's a positive association. A negative association, if you look very bottom of the page, a negative association, as one point rises, the other point decreases.
Oh.
So here, if I go along the x-axis, it's rising. But what is happening to the y?
It's decreasing.
It's decreasing. I end up with something like, whoop, that's a terrible line.
Magic.
And then we have the last one, which is no association. So positive association, it rises to the right. Negative association, it drops. No association, the data is just in a big fat group. The thing I showed you at first was no association. All that clothing, whether it looked good or bad, was easy to wear or not easy to wear, really had no association. There was no way to group it. It was just a lot of plots on there. if I did height and weight of all the 8th graders, I would get probably minor positive, but mostly it would just be a lot of dots, wouldn't it?
Yes.
It'd be a lot of dots because it's very hard to associate that. You all grow at different rates, so you really haven't stabilized yet. Does that make sense? Okay, so we can are you guys done? So we can further, if we get a positive or negative association. If we have no association, that's it. It's just no association. The data is just a big blot of dots. Leave it alone. If we get positive or negative, we can have linear, which means that basically, look down here at these examples, they're basically lying on a straight line, aren't they?
Yes.
They're linear. That's a terrible straight line down there. They're a linear association means I can draw a roughly straight line. I can make y equals mx plus b work at that point. It's a linear association. You're going to get some, and they're going to look, when they have nonlinear, they might do this, or they might do this, or it may do one of those where it kind of does this. It's nonlinear. It's not a straight line. We can see an association, but it's definitely not linear. It can still be positive. It can still be negative, but it can't be linear. Does that make sense? Mm-hmm. Any questions?